Hello my dear students, in this session we are going to discuss about the very important questions including PYQs of the chapter Carbon and its compounds. Okay, let's get started. First let us start with the 1 mark questions, that is MCQs. Let me read the first question. Which of the following is not a property of carbon compounds? And options are: carbon compounds are good conductors of heat and electricity, carbon compounds are poor conductors of heat and electricity, most of the carbon compounds are covalent compounds, boiling and melting point of carbon compounds are relatively lower than those of ionic compounds. We know that in case of carbon compounds, the type of bond that is formed is covalent bond. Covalent bond is seen in case of carbon compounds. And how does this bond forms? It is formed by the sharing of electrons. In this case, there is a mutual sharing of electrons. There is no transfer of electrons completely from one atom to another atom, because of which there is no availability of free electrons in case of covalent compounds. And also ions are also not formed in case of covalent compounds, because of which they are poor conductors of electricity. We know that in order to conduct the electricity, we should have either free flow of electrons or free flow of ions. But in this case, there is no presence of these free electrons or ions. So they are poor conductors of heat and electricity. Now, our question is, which of the following is not a property of carbon compounds? They have asked to choose that option which is not a property of carbon. So let's check. Carbon compounds are good conductors of heat and electricity. No, they are poor conductors of heat and electricity. So, this is not a property of carbon compounds. Whereas, let us check these. Carbon compounds are poor conductors of heat and electricity. Yes, this is a property of carbon compounds. And most of the carbon compounds are covalent compounds. Yes, this is also a property of carbon. Next, boiling and melting point of carbon compounds are relatively lower than those of ionic compounds. Because of weak intermolecular force of attraction, the boiling and melting point in case of carbon compounds, they are relatively low than those of ionic compounds. This is also correct property of carbon compound. So this is the only one which is not a property of carbon compounds. So our answer is A. The next question is, the given reaction is an example of, and the reaction is this. Here you can easily observe that there is a replacement of one hydrogen atom by one chlorine atom. This is substitution reaction, and there is no addition of any element here. The chlorine atom is being bonded to carbon by replacing hydrogen atom. So this is substitution reaction. So our correct answer is substitution reaction. Here we cannot say that it is displacement reaction, as these hydrocarbons, that is saturated hydrocarbons, are usually inert. And this reaction takes place in the presence of sunlight. So here we do not talk about the more reactive element which replaces another less reactive element here. So it is not displacement reaction. It is substitution reaction, that is substitution of hydrogen by chlorine atom. Yes, so our correct option is substitution reaction. Next, which of the following is the molecular formula of cyclobutane? First let us see how First, let us see how is the cyclobutane. In case of cyclobutane, there are 4 carbon atoms which are arranged in the form of ring, as the name itself suggests. Cyclo means the carbon atoms are arranged in the form of a ring. Butane suggests that it consists of 4 carbon atoms without any double bond. So all the bonds are single here. Now we have to satisfy the valencies by writing the hydrogen atoms here. See, this is the structure of cyclobutane. What will be the molecular formula of this cyclobutane then? C4H8 is the correct answer. We can see here the option C, C4H8 is the correct answer. Next question is, carbon forms 4 covalent bonds by sharing its 4 valence electrons with 4 univalent atoms. Example, hydrogen. Formation of 4 bonds, carbon attains the electronic configuration of. We know that every element tends to have completely filled valence shell. That is, the electronic configuration of the nearest noble gas is attained when the atoms are involved in bonding. So, in case of carbon, we can see it is having atomic number 6 and the electronic configuration is 2, 4. Now the question is, when it forms bond, that is covalent bond, by sharing its 4 electrons with 4 different univalent atoms, then carbon attains the electronic configuration of which noble gas? Okay, let's see here. When it shares its 4 electrons with univalent atoms. For example, let's see if it is sharing its electrons with hydrogen. It was having 4 valence electrons here, and when it forms bond with the 4 univalent atoms like hydrogen, then each covalent bond contains 2 electrons. Yes. Now you can see here, after sharing its electrons with 4 different atoms, then carbon will attain the electronic configuration of 2, 8. You can see here 1, 2, 3, 4, 5, 6, 7, 8. These are the electrons around the carbon atom. We are showing here only the valence electrons. Okay. So the electrons after making covalent bond will be 2, 8. That is, it is equal to the electronic configuration of neon. So the carbon attains the electronic configuration of neon. Okay. This is simply an example. You can take any example of carbon which forms covalent bond with any other atoms also. Okay. Which of the following does not belong to the same homologous series? CH4, C2, H6, C3, H8, C4, H8, C4H8. We know that for homologous series, the condition is the successive members differ by CH2 group. You can take any successive members, then the difference between their molecular formula will be by CH2 group. Let us check which will not belongs to the homologous series here. CH4. Okay. After CH4, the next successive member will be C2H6. Yes, the difference between these two is CH2 group. And after this, the next homologous member will be C3H8. Again, these two differ by CH2 group. So, all these are belonging to the same homologous series. Now, let us check the fourth member, C4H8. You can see here, between these two successive members, the difference between the molecular formula is not equal to CH2 unit. The difference between these two in case of molecular formula, it is not equal to CH2. So this is not belonging to this homologous series. All these three are belonging to the same homologous series as they differ in their molecular formula by CH2 group. Yes, this one is not belonging to this homologous series. Yes, the option D is the correct answer, as they have asked does not belong to the same homologous series. All these are belonging to the same homologous series, whereas option D, that is C4H8, is not belonging to the homologous series. Yes. Next, the most poisonous product formed by incomplete combustion of fossil fuels is carbon dioxide, nitrogen dioxide, carbon monoxide, sulfur dioxide. Among these, carbon monoxide is the most poisonous product that is formed by incomplete combustion of fossil fuel. In case of carbon dioxide, nitrogen dioxide, sulfur dioxide, even the long-term effect is not good, but this carbon monoxide is a very poisonous product as it decreases the oxygen carrying capacity of hemoglobin. Carbon monoxide decreases the oxygen carrying capacity of hemoglobin. When a person inhales this carbon monoxide, it will decrease the oxygen carrying capacity of hemoglobin, because of which it is very dangerous to health. Yes, among these, carbon monoxide is the very poisonous product. Next, the electron dot structure of chlorine molecule is. They have given these options. First, let us write the correct electron dot structure. Then we will come to know which one is the correct option. Yes, we know that chlorine has the electronic configuration 2, 8, 7, which means it needs one more electron in order to attain stable octet. Yes, we can show the valence shell electrons as 1, 2, 3, 4, 5, 6, 7. And for another chlorine atom, we can show 1, 2, 3, 4, 5, 6, 7. As each chlorine atom needs one more electron in order to have the stable octet. They will share one electron with other chlorine atom so that the stable octet is satisfied. There is a covalent bond between these chlorine atoms by sharing one electron, so that the number of electrons around each chlorine will be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is a correct structure of chlorine molecule. That is electron dot structure of chlorine molecule. Among these, which one is the correct answer? You can clearly see the option C is the correct answer here. Yes. Now, consider the structures of the three cyclic carbon compounds A, B, C given below and select the correct option from the following. Observe all these structures here. A and C are isomers of hexane and B is benzene. First, let us write the molecular formula of each compound here. In the first structure, that is A, the molecular formula is C6H12. In this case, the molecular formula is C6H6. Here also you can count the number of carbon and hydrogen atoms. The molecular formula will be C6, 1, 2, 3, 4, 5, 6, 7, 8. C6H8. Okay, now let us see the option. A and C are isomers of hexane and B is benzene. Yes, this is benzene which has the molecular formula C6H6. Whether A and C are isomers of hexane, isomers means what? We know that they are having the same molecular formula, but these two are not having same molecular formula, and it is not the molecular formula of hexane also. In case of hexane, we know that the molecular formula is C6H14. This is a molecular formula of hexane. But A and C, they are not having this molecular formula. So they are not isomers of hexane. This is the wrong option. Second, B option is A is an isomer of hexane, B is benzene, C is an isomer of hexene. Here also they have given A is an isomer of hexane. No, it is not an isomer of hexane, as hexane has the formula C6H14. But here you can clearly see it is having C6H12 and B is benzene. Even though this is correct, B is benzene, but this statement is wrong here. So this is also wrong option. Then A is saturated cyclic hydrocarbon and B and C are unsaturated cyclic hydrocarbons. This is saturated, yes, because there is no double bond between the carbon atoms. So this is saturated cyclic hydrocarbon. All these carbon atoms are arranged in the form of a ring. Then B and C are unsaturated cyclic hydrocarbons. These both are unsaturated because there is a double bond between the carbon atoms. In this case also and in this case also. So this statement is correct. And A is cyclohexane and B and C are the isomers of benzene. This is also wrong option. Yes, so our correct option is C here. Let me read the next question. In the above given reaction, alkaline KMnO4 acts as reducing agent, oxidizing agent, catalyst, dehydrating agent. You can clearly see in this equation that there is an addition of oxygen here. In this case, only one oxygen atom is present, whereas in the product, there are two oxygen atoms. So, there is addition of oxygen here. So, which type of compound will add the oxygen? Oxidizing agent is the compound which adds oxygen. So this alkaline KMnO4, it acts as oxidizing agent. The correct option is B. Yes. Next, ethanol reacts with sodium and forms two products. These are sodium ethanoate and hydrogen, sodium ethanoate and oxygen, sodium ethoxide and hydrogen, sodium ethoxide and oxygen. First, let us write the equation, then we will come to know the right option. Ethanol has the formula CH3, CH2, OH. It reacts with sodium to form CH3, CH2, ONA plus H2. See here, when this ethanol reacts with sodium, there is a formation of sodium ethoxide here. This product is called as sodium ethoxide. And there is a liberation of hydrogen. So let us check the option. Sodium ethanoate and hydrogen, this is wrong. Sodium ethanoate and oxygen, this is also wrong. Sodium ethoxide and hydrogen. Yes, there is a formation of sodium ethoxide. You have to remember the formula and also the name. This compound is called as sodium ethoxide. Eth means there are two carbon atoms here. Oxide. There is oxygen here. So it is sodium ethoxide. Okay. This is correct. Sodium ethoxide and oxygen. No, there is a formation of hydrogen here. So option C is the correct answer. Let's read the question. Following are the members of homologous series. This is assertion, and the reason, a series of compounds with same functional group but by differing by CH2 unit is called a homologous series. Now the options are both assertion and reason are correct, and reason is the correct explanation of A. Assertion and reason are correct, but assertion is not the correct explanation of A. Assertion is correct, but reason is incorrect. Assertion is incorrect, but reason is correct. So let us see the assertion and reason, whether they are true or false. Following are the members of the homologous series. You can check here, all these members have same functional group. They are having same functional group. And between the two successive members of this series, that is, let us check for first two members, CH3OH and CH3CH2OH. These two are differing by a molecular formula, that is CH2. Yes, you can see here CH3OH, CH3, CH2OH, CH3, CH2, CH2OH. In order to check whether these are members of same homologous series or not, we have to see whether there is difference in the molecular formula between the two successive members is CH2 or not. You can see here, between the CH3OH and CH3CH2OH, the difference in the molecular formula is CH2. And also you can check for these two successive members. Here also there is difference in the molecular formula by CH2 unit. So all these are belonging to the same homologous series. The assertion is correct. Reason is, a series of compounds with same functional group but by differing CH2 unit is called a homologous series. Yes. We know that when two successive members, they differ in their molecular formula by CH2 unit and they have same functional group, they are called as homologous series members. Means they are belonging to the same homologous series. So both assertion and reason are correct here. So the option A will be the right answer. Both assertion and reason are correct, and reason is the correct explanation of A. Okay. The next question is, draw the electron dot structure of the following, that is benzene and ethane. We know that benzene has a molecular formula C6H6, and in its structure the carbon atoms are arranged in the form of a ring, and also there is a alternate single and double bond between the two carbon atoms. Now we have to draw the electron dot structures. For this, you can easily observe that there is a sharing of two pair of electrons alternately. Here there is a sharing of two pair of electrons, means double bond indicates that there is a sharing of two pair of electrons. But there is double bond in an alternate manner. Yes, for this we can understand that alternately carbon is having double bond, means there is a sharing of two pair of electrons. So I can write it as they are arranged in the form of a ring, I will draw the ring structure for them. So there is alternate double bond here, Double bond indicates there is a sharing of two pair of electrons. So here I will show the sharing of two pair of electrons in a manner. Here I have shown two bonds. Alternately I will show sharing of two bonds here, means two pair of electrons, and alternate single bond means there is a sharing of only one pair of electrons, and the remaining valency of carbon is satisfied by hydrogen. All these are carbons, and with hydrogen also there is a sharing of one pair of electrons between these two atoms. So I will show it as two electrons here. This is how we can draw the electron dot structure for benzene. Alternately, there is a double bond between these two atoms, because of which we have shown two pair of electrons in an alternate manner. Yes, this is the electron dot structure of benzene. Now, electron dot structure for ethane. Ethane is having the molecular formula C2H6. The structure of ethane is like this. So let's draw the electron dot structure for ethane. These are carbon atoms which are linked to each other by single bond. So there is a single bond between these two carbon, which is shown by a pair of electrons. And for each carbon atom there is a bonding with hydrogen atoms, that is three hydrogen atoms. So we will show it: one hydrogen, two hydrogen, three hydrogen. Here also there is three hydrogen atoms, and all of them are single bonds. So we can show it by a pair of electrons. These two are carbon atoms. Surrounding this there are hydrogen atoms. Now this is how electron dot structure for ethane is shown. Yes. Now the next question is, state reason why carbon forms strong bonds and stable compounds with most other elements. The melting and boiling point of carbon covalent compounds are low. Let us give reason for the first question here. We have to give reason why does carbon forms strong bonds and stable compounds with most other elements. The reason is clear that carbon atom is having small size, because of which it enables the nucleus to hold the shared pair of electrons with strong force of attraction. So the bond formed by the carbon with other atoms is quite strong, because of which it will form strong and stable bonds with other compounds, that's with other elements. The small size of carbon atom enables nucleus to hold the shared pair of electrons with strong force of attraction. So it forms strong and stable compounds with other elements. As the size of carbon atom is small, because of which the shared pair of electrons are strongly held by the nucleus. As there is strong force of attraction between the nucleus and the shared pair of electrons, the bond formed between the carbon and other atoms of elements is quite strong. Yes. And also there is one more question here. The melting and boiling point of covalent compounds are low. And we know that when compared to ionic compounds, these covalent compounds are having low melting and boiling point. This is due to the reason that the intermolecular force of attraction is very low in case of covalent compounds. So less energy is required in order to melt or boil a covalent compound. It is due to the reason that intermolecular force of attraction is very low. Whereas in case of ionic compound, what was happening? There was a strong inter-ionic force of attraction, because of which it is not easy to melt or boil a ionic compound. Okay. Now there is one more question here. Draw the electron dot structure for the molecule of chlorine. This is very easy. For drawing the electron dot structure, you should know the valence electrons. Okay. Chlorine has atomic number 17 and its electronic configuration is 2, 8, 7. It is having 7 electrons in its valence shell. Okay. In order to obtain a stable octet, it needs one more electron. Okay. So it shares it one electron with other atom of chlorine. Yes. Resulting in the formation of chlorine molecule. Let us show the valence electrons here. 1, 2, 3, 4, 5, 6. There are 7 valence electrons. And in other chlorine atom also there is presence of 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Now by sharing these 2 electrons between the 2 chlorine atoms, there is a formation of covalent bond between the 2 chlorine atoms. This is how chlorine molecule is formed. Okay. Next, what is the role of concentrated sulfuric acid when it is heated with ethanol at 443 Kelvin? Give the reaction involved. First, let us solve the A question here. Understand the question here. When ethanol reacts with concentrated sulfuric acid, what happens? This is ethanol, CH3, CH2, OH. When it is heated with concentrated H2SO4, that is sulfuric acid. What happens? There is a removal of water molecule from this compound. Here the OH group of this carbon atom and hydrogen atom of this carbon atom are removed in the form of a water molecule, resulting in the formation of ethene. And there is a formation of double bond between the carbon atom, because we know that carbon atom is having valency 4, so it should have 4 bonds around it. So alkene is formed when ethanol is heated in the presence of concentrated H2SO4. Alcohol is converted into alkene here. The question here is, what is the role of concentrated sulfuric acid? What it has done here, it has removed a water molecule. So here it acts as dehydrating agent. The reaction is dehydration here. We have to show the water molecule also here. There is a removal of water molecule here. Okay. So this reaction is called as dehydration. So what is the role of this concentrated sulfuric acid? It acts as dehydrating agent. Concentrated H2SO4 acts as dehydrating agent. Then there is one more question here. Priya by mistake forgot to label the 2 test tubes containing ethanol and ethanoic acid. Suggest an experiment to identify the substances correctly. Illustrate the reaction with the help of chemical equations. We have to give the reaction in order to identify between ethanol and ethanoic acid. We know that when carboxylic acids are made to react with sodium carbonate or bicarbonate, there is a formation of salts, carbon dioxide and water. And in case of alcohols, they will not show any reaction with the sodium carbonate or sodium bicarbonate. This is how we can identify whether a given solution is ethanol or ethanoic acid. So let us write those equations here. The reaction which occurs when carboxylic acid reacts with sodium carbonate and bicarbonate, and how can we identify those compounds? Let us check here. Yes, when ethanoic acid is made to react with sodium carbonate, there is a formation of salt here, sodium acetate plus water plus carbon dioxide. And same with sodium bicarbonate. When ethanoic acid is made to react with sodium bicarbonate, there is formation of salt, that is sodium acetate plus water plus carbon dioxide. In both the cases, you can see there is a liberation of carbon dioxide gas. It will show brisk effervescence, because of which we can easily identify if there is a formation of brisk effervescence, then the given sample will be ethanoic acid. If there is no formation of any brisk effervescence, we can state that the given compound is not ethanoic acid. The left compound will be ethanol. Okay. So we can write the answer as with the reaction of. So how do you identify between ethanol and ethanoic acid? With the reaction of sodium carbonate or sodium bicarbonate, ethanoic acid will react to give brisk effervescence. Why there is a formation of brisk effervescence? It is due to the liberation of carbon dioxide there. Whereas ethanol, it will not react with these 2 compounds to form brisk effervescence. So there is no formation of brisk effervescence in case of ethanol. In this way, we will find out the given sample is either ethanol or ethanoic acid. We should write these 2 equations here. Okay. Now the next question is name the functional group present in each of the following organic compounds. CH3Cl. You can easily see here this is halogen. That is halo group is attached to here. That is chloro. The functional group is chloro here. In case of CH3OH, alcoholic group is attached here. OH means alcoholic group. And the next question is write the number of covalent bonds in the molecule of butane and ethane. In order to find the number of covalent bonds, you should know the structures. Yes? Let us write the structure of butane here. Butane indicates it consists of 4 carbon atoms. Ane means there is only single bond between the carbon atoms. This is the structure of butane. And let us write the structure of ethane also here. Ethane is having the formula C2H6. Butane has the formula C4H10. Ethane is having C2H6. Now you can count the number of covalent bonds here. In case of butane, let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. In this case, it is having 13 covalent bonds. You can see here the number of covalent bonds in ethane is 1, 2, 3, 4, 5, 6, 7. Here 7 covalent bonds. Once you know the structure properly, you can easily write the number of covalent bonds in the molecule. Now write the structural formula of butane and draw the complete structure of the molecule of cyclohexane and benzene. They have given the molecular formula also. There are 4 carbon atoms here. So in the first step, these carbon atoms are linked to each other by single bonds. We can write the carbon skeleton here. Then in the next step, we will satisfy the valency of each carbon atom by writing the hydrogen atoms. So for this carbon atom, there will be 3 hydrogen atoms. Already there is one bond here. So it will get 3 hydrogen atoms. For this carbon atom, already there is presence of 2 bonds here. So 2 hydrogen atoms are attached here. For this carbon also there is presence of 2 bonds already here. So I will write 2 hydrogen atoms here. For this carbon atom there is 1 bond here. The remaining hydrogen atoms are 3 which are to be written. So this is how we will write the structure of butane. And the name itself also indicates there is only single bond between the carbon atoms. So this is the correct structure of butane. Next the question is draw the complete structure of the molecule of cyclohexane and benzene. Let us write the next answer. We have to draw the complete structure for cyclohexane. Cyclo indicates that the carbon atoms are arranged in the form of a ring. Hex indicates that there are 6 carbon atoms. Ane indicates that there is only single bond between the carbon atoms. So let us write, as there are 6 carbon atoms, I will arrange them in the form of a ring as they have given cyclo. Now remaining valency of carbon is satisfied by writing the hydrogen atoms. Here the carbon atom is having 2 bonds. So the remaining 2 bonds are with hydrogen. For this also the 2 bonds are with hydrogen. In the same way I will write the hydrogen atom for all the carbon atoms. Yes, this is how the cyclohexane is. Next we have to write a structure for benzene. This is A and this is B. Benzene has the formula C6H6 and there is a alternate double bond between the carbon atoms. First let us write all the carbon atoms in the form of a ring. There are 6 hydrogen atoms here. 1, 2, 3, 4, 5, 6. So in order to satisfy the remaining valency, I should write the double bond here. And alternate double bond is present between the carbon atom. This is how benzene looks. Okay. Next the question is what are structural isomers? Draw the structure of 2 isomers of butane. Okay. Let us write the solution. Structural isomers, these are the compounds which have same molecular formula but different structures. The compounds having same molecular formula but different structures are called structural isomers. Yes, now we have to write the structure of 2 isomers of butane. Butane has 4 carbon atoms here. How can I write the butane? All the carbon atoms may be arranged in a straight chain. This is one possibility. And to write another isomers, I can write 3 carbon atoms in a straight chain and 1 carbon atom out of the chain. Now we can satisfy the remaining valencies of the carbon atom. Each carbon should get 4 bonds here as it is forming bond with hydrogen. This carbon also get 4 bonds. Already there is 1 bond here. Remaining 3 bonds are shown here. You can count the number of carbon and hydrogen atom. Here it is having C4H10. The molecular formula in this case also it is having 1, 2, 3, 4. C4 H10. 1, 2, 3, 4, 5, 6, 7, 8. We have to write here one more hydrogen. 7, 8, 9, 10. Okay. So both of them are having the same molecular formula but they are having different structures. Okay. This is how we can write the isomers. And explain with the help of structure why we cannot have isomers of propane. If I want to write the structure of propane, I can arrange all the carbon atoms in the form of a chain here. They have asked why can't we have the structural isomers for propane. Let us see. In order to arrange the carbon atoms in propane, I need to arrange in the form of chain here. And in order to get the isomer, I should write the branching carbon atom also. Okay. Whereas in case of propane, if I write the branching, again I will get all the carbon atoms in a same chain. You can write in any form. You can arrange these 3 carbon atoms in any form so that they will form a single straight chain. There is no possibility of branching in case of propane here, because of which the structural isomers are not possible. You can write this. All of them are having the same structure because they are having the 3 carbon atoms in a single straight chain. There is no branching here. For compounds to be different structurally, at least there must be branching there so that the compound will look different. Here, however, you arrange these 3 carbon atoms, all of them are in the same straight chain. Okay, this is why the isomers of propane is not possible. The reason is the branching is not possible in propane. You can write the structure of all these forms. You will get the same structure. You can observe here, all of them are having the same structure. All the carbon atoms are in a single chain. So, the isomerism is not possible in case of propane. Next, the question is, what is an oxidizing agent? What happens when an oxidizing agent is added to propanol? Explain with the help of chemical equation. Oxidizing agent is a compound which adds oxygen to another compound. Yes, which adds oxygen to another compound. And also we have to write what happens when an oxidizing agent is added to propanol. How to write propanol? CH3, CH2. This is propanol. When an oxidizing agent like alkaline KMNO4 is added to propanol, it is oxidized to corresponding carboxylic acid. Here it is having 3 carbon atoms in the propanol. The resulting carboxylic acid will also be having 3 carbon atoms. So that the formula will be CH3, CH2, COOH. This is the carboxylic acid. When propanol is treated with alkaline KMNO4, what happens? There is a formation of corresponding carboxylic acid here. It is propanol, it is propanoic acid. If you take ethanol, we will get ethanoic acid. If you take propanol, we will get propanoic acid in this way. Yes. The next question is, with the help of an example, explain the process of hydrogenation. Mention the essential condition for the reaction and state the change in physical property with the formation of the product. What do you mean by hydrogenation? Hydrogenation is the process of adding hydrogen molecule to an unsaturated compound. Hydrogenation is a process of adding hydrogen molecule to an unsaturated compound. Means the compound which has double or triple bond. Mention the essential condition for the reaction and state the change in physical property with the formation of product. First, let us take an example here. The unsaturated compound means it has double or triple bond. Let us take an alkene here. When it undergoes hydrogenation in the presence of nickel or palladium catalyst, there is a formation of saturated compound here. When this reaction takes place, the essential condition is the compound must be unsaturated. Essential condition, the compound must be unsaturated. And also for this reaction there is a necessary of catalyst, and also the catalyst is needed. For this reaction, nickel or palladium catalyst can be used for hydrogenation reaction. And we have to state the change in physical property with the formation of the product. And the most familiar example for hydrogenation is hydrogenation of vegetable oils. Hydrogenation of vegetable oils to vegetable fats. When the hydrogenation takes place, you can easily observe that when these oils are converted into fats, there is increase in density, and also liquid is converted into solid. So the change in physical property is, this is just for explanation of the example. Yes, we have to write the change in physical property. Physical property. What happens? There is change in density, that is increase in density, and also there is change in physical state. Change in physical state from from liquid to solid. These are some of the changes in physical properties that can be seen when the hydrogenation takes place. You have to mention these changes. So the answer will be hydrogenation is a process by adding, it is a process of adding hydrogen molecule to an unsaturated compound. And also you have to mention the essential condition. What is that essential condition? It is the compound must be unsaturated, and also the catalyst is needed for the hydrogenation reaction. And also they have asked that what is the physical property change that is seen when hydrogenation takes place, that is increase in density and change in physical state from liquid to solid. Okay. The next question is, an organic compound P is a constituent of wine. P on reacting with acidified K2Cr2O7, that is potassium dichromate, forms another compound Q. When a piece of sodium is added to Q, a gas R evolves which burns with pop song. Identify P, Q and R, and also write the balanced chemical equation of the reactions involved. They have mentioned that P, it is a constituent of wine, and it shows that the compound P must be an alcohol, and that alcohol which is constituent of wine is ethanol. We all know that ethanol is a constituent in all alcoholic drinks. Yes, it must be ethanol. And also they have given P on reacting with acidified potassium dichromate forms another compound Q. Let's see what is that Q that is formed after reaction with potassium dichromate. Now we have confirmed that the P is an ethanol. Why? Because it is said that it is constituent of wine, and wine is an alcoholic drink. Okay, that alcohol which is used in preparation of wine is ethanol. Okay, so this is ethanol. When we make the reaction of ethanol in the presence of acidified K2Cr2O7, what is this? This is an oxidizing agent. Acidified K2Cr2O7. It is an oxidizing agent. What happens? The oxidation of ethanol takes place to form ethanoic acid. There is a formation of ethanoic acid here. This is ethanoic acid. This is ethanol. And they have given the compound Q is formed, which means this is Q. We have found out the P as ethanol and Q as ethanoic acid. And again they have given that when a piece of sodium is added to Q, a gas R evolves which burns with pop sound. When a gas burns with Pop sound, it indicates that the liberated gas will be hydrogen. Okay, we have to identify R now. That is, we have to say the balanced chemical equation for the reaction involved. Yes, when Q is made to react with sodium, that is ethanoic acid. When ethanoic acid is made to react with sodium, there is a formation of sodium ethanoate, okay, along with the formation of hydrogen gas. So this is the reaction that takes place when ethanoic acid reacts with sodium metal, and this will be R. Okay, now we have found that P is ethanol, Q is ethanoic acid, and R is hydrogen. And they have also given to write the balanced chemical equation for the reaction involved. Yes, in the first step, we have seen the reaction that takes place when ethanol reacts with acidified potassium dichromate. There is a formation of acid, that is ethanoic acid. And in the second reaction, what they have asked, when a piece of sodium is added to Q, means Q is ethanoic acid. What happens here? There is formation of sodium acetate or sodium ethanoate. It is called as sodium ethanoate. Also, we have to balance the equation. Yes. Now, P is ethanol, Q is ethanoic acid, R is hydrogen. And also, we have written the chemical equations for the reactions. Next, the question is two different forms of carbon, diamond. Next, the question is two different forms of carbon. Diamond and graphite have different structures and very different physical properties, even though their chemical properties are same. Explain why. We know that diamond and graphite, they are allotropic forms of carbon, means they have same chemical composition, only they have different structural arrangement. Because of the different structures, they show different physical properties. Yes, in case of in diamond, each carbon atom is attached to four different carbon atoms to form rigid three-dimensional structure. Because of this formation of rigid three-dimensional structure, the diamond is very hard, giving extreme hardness to it. Why they are having physical properties that is different? Because of their structural arrangement. Let's see what happens in case of graphite. In graphite, each carbon atom is attached to three different carbon atoms in the same plane, forming hexagonal array. In case of diamond, what has happened? Each carbon atom is attached to four different carbon atoms, and this carbon atom is again attached to four different carbon, and this carbon is again attached to four different carbons. In this way, there was formation of a rigid three-dimensional structure. Whereas in case of graphite, the carbon atoms are linked to three different carbon atoms. Each carbon atom is linked to three different atoms, forming a hexagonal array. This is attached to three different atoms in this way. In this way, they are in the same plane. And in these structures, there are different planes which are present one above the other. Yes, the different hexagonal array of carbon atoms are present one above the other. They have formed a sheet-like structure. They are not having here a network-like structure. Three-dimensional network structure is not present here. There is a formation of plane structure in the form of hexagonal rings, and these planes or the sheets are arranged one above the another, because of which there is a formation of some space between these layers, and between these layers there is a presence of some space, so that the layers can slide over each other, resulting in the softness and sliding nature of the graphite. The space between the layer of these hexagonal sheet-like structures causes sliding between the layers, giving soft and sliding properties. What happens here? In case of graphite, each carbon atom is linked to three other carbon atoms in the form of a hexagonal rings. And these hexagonal arrays, they are arranged layer by layer. And there is some space between these layers, because of which these layers will slide over each other. There is no rigid structure for this graphite, which causes a softness and sliding properties to graphite. This is why there is difference in the physical properties of diamond and graphite. Even though they are having same chemical composition, the arrangement of the atoms is completely different. You can see here all the carbon atoms are linked to three different carbon atoms. This is why there is difference in the physical properties of diamond and graphite. The next question is, first, state any three physical properties of carbon compounds. Next, carbon is a versatile element. Justify this statement. Give the structural difference between unsaturated and saturated hydrocarbons with two examples each. And also, you have to say what is functional group. Give examples of four different functional groups. Let's answer one by one. The three physical properties of carbon compounds are, they have low melting and boiling point. Because of weak intermolecular force of attraction, their melting point and boiling point are low. And also, the force of attraction between the molecules is less. And one more property of carbon compounds is, they are poor conductors of electricity. As free electrons or ions are not present, they are poor conductors of electricity. Let's write them. They have low melting point and low boiling point. And also they are poor conductors of electricity. The intermolecular force of attraction is weak. Next we have to write the answer for this question, that is, carbon is a versatile element. Justify this statement. Why carbon is called as a versatile element? It is mainly due to its properties, that is catenation and tetravalency. What is the catenation? Catenation is the property by virtue of which it can form bonds with other carbon atoms, resulting in the formation of large molecules. Yes. And what is the property of tetravalency? It is having valency 4, so that it can form bond with 4 other atoms, resulting in the formation of large number of compounds. And that too, it forms stable compounds because of small size of carbon atoms. Yes, because of these two reasons, carbon is a versatile element. Catenation property, you have to write both catenation property and tetravalency. And also you have to mention what these properties are. Catenation property means it is a tendency to form bond with other carbon atoms to form large molecules. Then tetravalency is, it can form bond with 4 different atoms of other elements also. It can form bond with carbon atom also, and also with atoms of other elements, and it forms such a stable bond with those atoms of elements. Okay. And also they have asked, give the structural difference between saturated and unsaturated hydrocarbons. Saturated means having carbon-carbon single bond. Carbon-carbon single bond. And unsaturated means having double or triple bond. Having carbon-carbon double or triple bond. Okay. We have to give examples for them. For saturated hydrocarbons, you can give methane, ethane, C2H6, and for unsaturated, you can give C2H4, that is ethene, propene. You should also name these compounds. It is methane, ethane. It is ethene. It is propene. Okay, these are some examples for saturated and unsaturated compounds. You can also give examples of alkynes also. Okay. Next, the question is, a compound X undergoes addition reaction with hydrogen to form a compound Y, having molecular mass 30 gram per mole. X decolorizes bromine water and burns with a smoky flame. Identify X and Y and write the chemical equation of the reactions involved. We have given a compound X undergoes addition reaction with H2 to form a compound Y having molecular mass 30 gram per mole. Let's take example of ethene here because it is given in your textbook. Okay. For first question, when it undergoes hydrogenation in the presence of nickel or palladium catalyst, there is a formation of ethane. It is ethene and this is ethane. Let us check the molecular mass here. The atomic mass unit of carbon is 12. There are 2 carbon atoms here. So 2 into 12 plus the atomic mass unit of hydrogen is 1. So there are 6 hydrogens here. 6 into 1. So I will get 12 to 24 plus 6, 30. So our compound that is formed is conformed. That is ethane. How ethane is formed? It is formed from the hydrogenation of ethene. Okay. Now this is X and this compound is Y. And they have also given X decolorizes bromine water and burns with a smoky flame. When bromine water is added to unsaturated compounds, they will decolorize the bromine water, which shows it is having double bond. And also they have said it will give a smoky flame. Which type of compounds will give smoky flame? Unsaturated compounds will give smoky flame. So our compound ethene is confirmed. Okay. Then identify X and Y. We can write here X is ethene, Y is ethane. And write the equations for the chemical reactions involved. This is the hydrogenation reaction of ethene. And we need not write the reaction for the decolorization with bromine water as it is not given in your syllabus. Okay. Then the question B is, write the structural formula of butanone and pentanoic acid. For writing the structural formula, first we have to know how many carbon atoms are there in this compound. Yes, in butanone, it is clear that there are 4 carbon atoms. And also we have to identify the functional group. That is one given here. Means ketone is present. It is ketone. Ketone is having the formula C double bond O. So we have to write the structure for butane. C, 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 as there are 4 carbon atoms, and we know that always this ketone group is present in the middle of chain. These 2 free bonds are connected to 2 other carbon atoms. So I can take either C double bond over here or here. Both are same. Okay, let's write here. Then satisfy the valency of carbon with hydrogen atoms here. 1, 2, 3, 4. Already there is presence of 4 bonds around this carbon atom here. 1, 2, 3, 4. So there is no need to write hydrogen here. Here already there are 2 bonds. So I need to write 2 hydrogen atoms. For this 1, 2, 3. This is the structure of butanone. And also we have to structure for pentanoic acid. Pentanoic represent that it contains 5 carbon atoms and the functional group is OIC, means it is carboxylic acid. Okay, C, 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 C. 5 carbon atoms are present. And the functional group is carboxylic acid. It has a formula C double bond O OH. This is the functional group. Then remaining valencies are satisfied with hydrogen here. Always remember the carbon should get 4 valence electrons to be bonded with 4 other atoms. It should have 4 bonds around it. Here carbon is having double bond with oxygen, so we need not write another hydrogen atom here. Already there is a presence of 2 bonds here, third bond is here, fourth will be with carbon, so no need to write the other hydrogen atom here. Okay, this is pentanoic acid. Let's move to the next question. A student adds 2 ml of acetic acid to a test tube containing 2 ml of distilled water. He then shakes the test tube well and leaves it to settle for some time. What are the observation after some time? We know that acetic acid is soluble in water. Once it is dissolved in water, it forms a clear colorless solution. Okay? Acetic acid is soluble in water. So, it gives a clear colorless solution in water. This is the observation that we can make when acetic acid is dissolved in water. Okay. Next, hard water is not available for an experiment. Some salts are given below. That is sodium chloride, sodium sulfate, calcium sulfate, calcium chloride, potassium chloride, magnesium sulfate. Select from the following a group of these salts which each member of which may be dissolved in water to make it hard. We know that hard water contains calcium and magnesium salt. Why it behaves as hard? Because of presence of calcium or magnesium salts in it. And these ions makes the water hard. Now we want to prepare the hard water for an experiment purpose. These are the salts which are present, means which we are given. So by dissolving which salts, I will get a hard water. Let's check here. Sodium chloride. It will not form any calcium or magnesium ion. We cannot use it. Sodium sulfate also, it will also not form calcium or magnesium ions. Then calcium sulfate, yes, this can be used for making it hard. And calcium chloride also be used for making the water hard. Then potassium chloride cannot be used for making the water hard. Then magnesium sulfate, it can be used. The calcium and magnesium salts will make the water hard. So which are the salts that may be dissolved in water to make it hard? They are calcium sulfate, calcium chloride, magnesium sulfate. Yes. Now distinguish between esterification and saponification reaction with the help of chemical equation for each. What is esterification? It is a reaction between carboxylic acid and alcohol to form ester. Esterification, it is reaction between carboxylic acid and alcohol to form ester. And they have also asked to write the chemical equation. Yes. Let us take example of ethanoic acid here. When ethanoic acid reacts with ethanol, there is a formation of ester, that is CH3 CO O CH2 CH3. There is a removal of water molecule. It is ethyl ethanoate. Ethyl ethanoate. This is esterification reaction. Then what about saponification reaction? Saponification reaction is the reaction of ester with sodium hydroxide. Yes, it is reaction of ester with sodium hydroxide. We can say that the reverse reaction takes place when this reaction is carried out with sodium hydroxide. Means when ethyl ethanoate, that is ester, is made to react with sodium hydroxide, the reverse reaction takes place to form sodium salt of acid and ethyl alcohol. Takes place in the presence of acid. This saponification is the reaction between ester. That is, we can take CH3, CO, CH2, CH3. It reacts with sodium hydroxide to form salt of carboxylic acid, CH3, CO, Na plus ethanol, CH3, CH2OH. This is sodium ethanoate. This is called as saponification reaction. As this reaction is used in the preparation of soaps. This is saponification. Okay. This reaction is used for the preparation of esters. These esters are sweet smelling. They are having pleasant smell. So they are used in the preparation of perfumes, paints, dyes, etc. Whereas saponification reaction, it is used in the preparation of soaps. Yes. Let's move to the next question. Name the functional group present in the following compounds. Here you can clearly see that COOH is present. This is carboxylic acid. The functional group present here is carboxylic acid. Here COH is present. It is aldehydic group. This group is called as aldehydic group. So aldehyde. The functional group present here is aldehyde. And here you can see OH group is present, means it is alcoholic group. And here the group present is ketone, means C double bond O is present in the middle of the carbon chain, means this group is called as ketone group. And the functional group is ketone. These are the different functional group of these compounds. Okay. What is the difference between the molecules of soaps and detergents chemically? Explain the cleansing action of soaps. We know that soaps are chemically, these are sodium or potassium salts of carboxylic acid, that is long chain carboxylic acid. What are these? These are sodium or potassium salts of long chain carboxylic acids. Whereas detergents, these are ammonium or sulfonate salts of long chain carboxylic acid. These are or sulfonate salts of long chain carboxylic acid. Both of them are chemically different. Yes. Now we have to explain the cleansing action of soap. We know that soap molecule consists of two different parts. One part is hydrophilic part, another one part is hydrophobic part. This is hydrophilic. We can represent the soap molecule in the form of a tadpole structure where one part consists of ionic part and another one is hydrocarbon chain. This is hydrophobic. The hydrophilic part is soluble in water and hydrophobic part is soluble in hydrocarbons. And if we want to remove the dirt which is in the form of oil or grease, what happens? The hydrophobic part of the soap molecule will interact with the dirt containing oil or grease, resulting in the formation of a cluster. Suppose this is a dirt containing oil or grease. Now what happens? This hydrophobic part which is soluble in hydrocarbon, it will interact with this oil or greasy material so that a cluster is formed like this. Suppose this is soap molecule. We know that sodium stearate C17H35COONA. This is a soap molecule. This part is hydrophobic. This is a long chain containing 17 carbon atoms. And this part is ionic, that is hydrophilic, which has affinity towards water. What happens when I can represent this molecule in the form of a tadpole structure like this? This part will interact with the oil or dirt, and this ionic part will be dissolved in water, so that there is a formation of cluster in this way, and this dirt is present in between these cluster. As you rinse the cloths, as you agitate the cloths, these cluster will be come out of the cloth and get dissolved in water, which can be removed easily by washing it with plenty of water. In this way, the cleansing action of soap takes place. Yes, we have to write here. Soap's molecules are sodium or potassium salts of long chain carboxylic acid. Detergents molecules are the ammonium or sulfonate salts of long chain carboxylic acid. How the cleaning action of soap takes place? The dirt present on cloths are organic in nature, means they are in the form of oil or grease, and it is insoluble in water. When soap is dissolved in water, the hydrophobic ends of soap molecule attaches to the dirt and remove it from the cloth. Then the molecules of soap arrange themselves in micelle formation. Whatever the cluster we have seen, this cluster it is called as micelle. Yes, and trap the dirt at the center of cluster. These micelles remain suspended in water, hence the oily dirt is easily rinsed away by water. It is rinsed. This is how the cleansing action of soap takes place. Next, the question is, how would you bring the following conversion? Ethanol to ethene. When we convert ethanol to ethene, we need a dehydrating agent. This is a dehydration reaction. Take example of ethanol here, CH3, CH2OH. When this ethanol undergoes dehydration in the presence of dehydrating agent, that is concentrated H2SO4, there is a removal of water molecule resulting in the formation of ethene, and the double bond is formed between the carbon atoms. As carbon atom is having valency 4, it should get 4 bonds around it. Yes, this is the first answer. The second answer is propanol to propanoic acid. This is propanol. Propanol is having 3 carbon atoms. If we want to convert propanol to propanoic acid, we need oxidizing agent. Yes, we can take alkaline KMnO4. It is an oxidizing agent. It will convert propanol to propanoic acid. CH3, CH2, COOH. And that acid is formed which has same number of carbon atoms as in case of alcohol. This is propanol. This is propanoic acid. And the very important agent that is needed for this reaction is oxidizing agent. This is oxidation reaction. Yes. Hard water do not produce foam with soap easily. Why? We know that hard water contains calcium or magnesium ions. The salts of calcium and magnesium are present in hard water. What happens is they will replace the sodium or potassium ions of soap molecule. Suppose this is soap molecule. These Na plus or K plus ions of the soap molecules are replaced by these calcium or magnesium ions, which results in the formation of insoluble product that is called as scum, replaced by calcium or magnesium ions, resulting in the formation of insoluble precipitate that is called as scum. So, because of the scum formation, the soap will not produce foam with hard water, and also it will not show good cleaning action in case of soaps. And because of formation of this scum, the soap will not clean the clothes efficiently. Yes, you have to write soaps contain sodium or potassium salts of long chain carboxylic acid. When soap is dissolved in hard water containing calcium and magnesium ions, these ions replace the sodium and potassium ions from their salt to form insoluble calcium and magnesium salts, carboxylic acid. These insoluble salts form the scum. Yes, when these ions are replaced by this calcium or magnesium ions, there is a formation of salt that is insoluble. It is called as scum. Because of formation of scum, the hard water will not produce foam with soap easily. Yes, this is the answer for this question. Yes, this is all about the most important questions and PYQs of the chapter carbon and its compounds.